Inside a modern industrial automation cabinet, rows of physical hardware handle the critical task of managing sensor data and motor control. To the end user, these I/O components are sealed, proprietary black boxes. Regardless of the closed exterior, international copyright law requires manufacturers to publish a specific legal document, an open-source software declaration. These compliance PDFs list the specific third-party libraries embedded in the device, acting as a forensic map of the system's interior. By analyzing the libraries listed in this document in sequence, we can map out the entire embedded software stack running inside the node. This process allows us to isolate the software architecture directly from the physical silicon. Decoding this document reveals the specific tools that power modern industrial automation. Every embedded system requires a base layer to translate software commands into raw silicon voltage. This is the hardware abstraction layer, or HAU. Scanning the BECKHOFF declarations, we find the libraries serving this function: ARM CMSS, PIC peripheral libraries, and STM32Cube. These layers utilize different licensing models. ARM CMSS operates under the permissive Apache 2.0 license, allowing for broad integration. However, the ST microelectronics software in this device operates under a highly specific license known as SLA0044. This license dictates that the code is open source, but it must be used and execute solely and exclusively on a microcontroller manufactured by ST Microelectronics. Silicon vendors use this model to provide the necessary integration code while legally tethering that code to their specific hardware products. At the lowest level of the stack, open source software is used to reinforce hardware dependency. Above the silicon control layer, the device requires a system to manage execution and prioritize time-sensitive tasks. The declaration document identifies FreeRTOS as the core operating system for the module. Industrial applications require deterministic task scheduling, ensuring that every operation executes within a predictable and rigid time window. In an I/O module, millisecond delays in managing physical inputs can cause machine failure. FreeRTOS provides the precise timing necessary to prevent these collisions. Because it utilizes the MIT license, FreeRTOS is legally straightforward for manufacturers to integrate into commercial industrial hardware. The absolute timing of the device relies on a permissive, community-maintained tool. Once the internal tasks are managed, the node must communicate its data to the broader industrial network. We find LWIP, or lightweight IP, listed in the declarations. This library provides a full TCP IP stack specifically designed for microcontrollers with constrained memory limits. Modern industrial security requirements have shifted. Devices can no longer assume they are protected by a physical air gap. The document identifies mbed TLS as the provider of cryptographic primitives, enabling TLS and SSL encryption for the node. These two libraries work together to ensure that network packets are correctly routed and secured against unauthorized access. For this specific device, communication security is built on the audited strength of open-source cryptography. The highest level libraries listed in the document reveal the advanced capabilities of the hardware. The inclusion of FATFs and libjpeg shows that the device manages localized file systems and handles image data. Local file systems allow the node to store configuration and log data locally without requiring constant network access. libkpeg indicates the device can process visual data, which is used to host web-based diagnostic interfaces directly from the node. These high-level utilities provide modern I/O nodes with the processing power of capable edge computers. When this software stack is sealed back inside the physical hardware, the nature of the device changes. This proprietary industrial node is a curated ecosystem of open-source foundations. The manufacturer's primary value is the rigorous integration of these tools, the physical hardware design, and the formal safety certifications required for the factory floor. Using these community foundations creates a strict legal obligation for the manufacturer. In Appendix 3.1 of the BECKHOFF document, the company confirms this compliance, offering a physical copy of the relevant source code for a processing fee of €5. Maintaining this transparency is a legal requirement for the manufacturer to sell their hardware globally. The next time you see a piece of proprietary industrial hardware, remember the open-source architecture running silently inside.
Thanks for watching and grow every day with just a bit of information. Like and subscribe for more content and learning.